There are hundreds of millions of exoplanets out there, and more are discovered every day. Currently, we are aware of no other planet like ours anywhere in the universe. However, scientists now claim to have discovered exoplanets that may be even more habitable than the Earth. Do these exoplanets actually exist? Any planet outside of our solar system is called an exoplanet or extrasolar planet. Exoplanets can be any size, from gas giants larger than Jupiter to small rocky planets like Mars and Earth. The majority of the planets that have been found are located in a small area of the Milky Way galaxy, and we know from observations made by NASA's Kepler Space Telescope mission that there are more planets than stars. The first exoplanets were found in the 1990s, and since then, many more have been found using a variety of techniques, albeit it's not always simple to detect them. The U.S. Space Agency's Kepler Space Telescope spent 9 years on a planet hunting mission and identified thousands of these exoplanets in our galaxy before it ran out of fuel in 2018. After going through all the data Kepler collected, those 300 million rocky planets could be capable of supporting liquid water on their surface. This is just a rough estimate, as there are between tens of thousands and hundreds of millions of rocky planets in our galaxy alone. The term superhabitable was coined by two researchers in 2014 who claimed that it takes more for an exoplanet to be habitable than simply being in the habitable zone. Factors that would make a planet more suitable for life as we know it include older, larger, warmer, wetter, possibly having higher levels of oxygen, and having a star that has a longer lifespan. The 24 superhabitable exoplanets were selected because they have a star of the right size lifespan and lie in the habitable zone. Many of these orbit around G-dwarf stars similar to our Sun, but researchers also look to other stars. Heller and Armstrong have proposed that the required size of a super-Earth would have to be 2 Earth masses because radioactive decay in the planet's interior would last longer to provide heat, and the stronger gravity would hold on to the atmosphere longer. A planet orbiting a K-star would have much more time to evolve than life on Earth has thus far, given that complex life took 3.5 billion years to evolve on Earth and 4 billion years for advanced life such as humans. While these sun-like stars might not sound ideal for life, they have a big advantage. Their lifetimes range from 17 billion to 70 billion years compared to the 10 billion year lifespan of our Sun. A more superhabitable planet would obviously need water for life as we know it to survive, but planets with more moisture and an average surface temperature 8 degrees Fahrenheit warmer than Earth could make them more habitable, since we know there is more diversity of life in warmer and wetter climates, and some of these more habitable planets could resemble the Earth. The next nearest superhabitable exoplanet is called 667 cc, and it orbits a red dwarf star in the Gliese 667 triple star system. Yes, if you were on Gliese 667 cc, this is probably what you would see in the day sky. Gliese 667 cc is located 23.62 light-years from Earth and has a minimum mass of 3.7 Earth masses. Some authors speculate that there may have been an ancient civilization on the exoplanet or the moon orbiting it, but it's also possible that we are now seeing a glimpse of the future fate of Earth because the star it orbits used up its fuel and has expanded into a red giant. Kepler 452b, also known as Earth 2.0, orbits a G-type star that is very similar to our Sun, except that it is 1.5 billion years older and slightly bigger. Despite all of this incredible technology, if a planet orbiting a red dwarf has an atmosphere similar to Earth's, it will need to be within 16 light-years for the James Webb Telescope to detect it. The new technique, according to researchers, will allow the Webb telescope to detect a unique signal produced when oxygen molecules collide. If this signal was found in an atmosphere of an exoplanet, that would mean it had oxygen and possibly life as we know it on the planet's surface. We may need something more powerful to look farther into space. The Nancy Grace Roman telescope will be launched sometime in the later 2020s and will have 100 times the viewing field of the Hubble Space Telescope. It will probe the dark depths of dark matter and the evolution of our solar system. After its 2021 launch, the James Webb Telescope will study the history of our universe, including distant exoplanets, other galaxies, and the first luminous glow of the Big Bang. The ability to take direct pictures of exoplanets, something not feasible from Earth, is what excites me the most. However, the major objective of the project is to look into the Milky Way galaxy's interior, where gravitational microlensing may help identify thousands of more exoplanets. However, if we do discover life elsewhere in the cosmos, we must keep in mind that it may not exist in the same manner as we typically imagine on Earth, such as on superhabitable worlds. With so many livable planets in the universe, it's probable that we'll eventually find life on another planet when human technology enters a really exciting period.